So now we're going to learn about the fundamental theorem of linear programming. I like the term, actually, linear optimization. Instead, because linear optimization makes more sense to me. It's talking about optimizing the value of something or the cost of something more, usually is what we're going to talk about. So the fundamental theorem of linear programming or optimization says that if you have a region, so yesterday we learned about regions like a polyhedron, and we'll talk about that in a second, the minimum or maximum value of some objective function will occur always at one of the corner points. So yesterday you spent a lot of time graphing and then finding those corner points. So today we're going to figure out which one of those gives us the optimal value, either a minimum or maximum. Sometimes we need either. So here's an example like you'll see on your homework today. So we're going to minimize, this is our objective function. The objective function is one that's set apart without a inequality. So you can usually identify it, it's equal to. And we give it a bunch of constraints. So this is what you did yesterday. You took a bunch of constraints and you graphed them. So I graphed them over here. Well, actually, I'm sorry, the first thing I did was I put them all in y equals form, because if you want to use your graphing calculator, you have to have y by itself. So for, I just did this all for you so I don't have to waste time doing it on the tape. But I set all of them equal to y, and then make sure one of them I know I had to, the second equation, I had to flip my sign because I divided by a negative. So make sure that you remembered if you're multiplying or dividing by a negative, you switch your signs. So then what I did is, and this is kind of a new trick, especially if you have 3 lines. With 2 lines it's maybe not as important, but for 3 lines especially, and your textbook doesn't do this, I always give my lines L1, L2, or L3 because it helps me to identify which line is which. So if you're lucky enough to have a color graphing calculator, then you probably won't have any issues because it color codes everything. But if you don't have a color graphing calculator, you are going to need to make sure you know which line is which. So for example, I came over here, so here are my 3 lines. We almost always, actually I believe we always, have the constraint that x and y both have to be greater than 0. So we only want to deal in the first quadrant. We want all of our x's and y's to be positive. So I went over here and I graphed my lines, and see how I labeled them L1, L2, and L3. And the reason that that's important is because obviously we're going to be looking for all of these corner points, right? We're going to be looking for, there are 4 corner points to this graph, but I need to know this corner point is the intersection of L2 and L3. It's not, L1 and L2. Actually, L1 and L2 is down here. So make sure you know when you go to set these 2 equations equal to each other to find that point. So L2 and L3, I would set these 2 equations equal to each other. So it would be 2x equals negative 2x plus 200. That would give me my x value, and you know how to do the rest. So, it just helps to label them. And then also make sure that you're using your arrows correctly. This one actually was a little confusing because can you see that you have 4, actually you have 4 possible polyhedrons. A polyhedron is just a multi-sided convex shape. Sorry, lost my train of thought there. But notice the only quadrant where all the arrows greater than or less than are pointing at each other is in this quadrant. So be very careful. Make sure you're putting all those arrows in this section of the graph that you want is where everything is pointing towards each other. So I came up with this, and then I would find this point and this point. Don't forget to also find your points that if your area includes intercepts. So this is the y-intercept of L1, and this is the y-intercept of L3, which is pretty easy to find over here. So make sure you're considering all those points. So you would have 4 points listed. And then the whole point of optimizing is simply taking all 4 of those points, whatever they are, all 4 of those points, and plugging them into the objective function, or the cost function, and seeing which one either gives you the maximum value or the minimum value. So that's what you're looking for. So, I don't know what they are. I'm just making up some numbers. So let's say I had 30, 50. Let's say that was one of mine. I would plug it in here and see what value I get. Put that aside, then I would check the next one. Say, oh, this can't be negative, right? Let's say I had 20, 100. Then I would take that and plug it into the function and see. And then make sure you're paying attention. Sometimes we ask for the minimum, and sometimes we ask for the maximum value. And it could be, again, the intercepts. Sorry. So, and remember, these points I just made up off the top of my head. Those are not real. Okay, and the last thing you need to know is how to convert a word problem. So this is from your textbook. It is not a homework assignment, but you'll have some similar to it. This is problem 36, and it's a word problem that talks about a school program taking some buses and vans. So we're going to obviously take a bunch of students and some chaperones, and it tells us how many each bus and each van can hold. And then it always tells us, it always will give you cannot take more than, so, or something like that. So I had a bus can hold 40 students, and a van can hold 8 students, and I want to take at most 400 students, so it has to be less than 400. And then the chaperones, I can take 3 and 1, and I want to take at most 36 chaperones on my trip. And then the other trick to that, so obviously we can just assign these guys variables. So I did 40x plus 8y is less than 400, or less than or equal to, and 3x plus 1y is less than or equal to 36. I think it helps to set up your table, so try to pull out all the data from the word problem and try to set it up. You're going to have generally 2 kinds of variables that are alike, buses and vans and people over here, and just set up a table and see if you can do that. And then you always are going to have the constraint x has to be greater than 0, y has to be greater than 0. And the last thing is you're going to have this is your objective function or your cost constraint. This is generally going to be where you're going to put your money together. So notice that the 40, the 8, the 3, and the 1 had nothing to do with money. That was just number of people. But your cost function, because that's what you're trying to generally, in word problems, you're generally trying to optimize your cost, how much it's going to cost you. And so think about just putting the money together. And that is almost always, as a little trick, is almost always going to be your objective function. So anyway, I went ahead and just did a basic graph of this on the calculator. Notice that I labeled L1 and L2 for those of you without the graphing calculator. Because again, I've got 3 different possible sections. Do not always assume that it's this bottom section. Just like the problem I did before was not near the origin. Some people make the mistake that assume that your polyhedron area is always going to be the one down in the corner. It is not necessarily always down there. And I think that's about it.